Okay, reduction formally continued, and this is 180 plus. Now I'm going to go a bit quicker for each of these, and if you're unsure, then go back to the previous video. So our starting point is our Cartesian plane. X, Y, there it is. We've started with a point in the first quadrant, and that point is AB. And nice, draw a little triangle. This forms an angle theta from the positive axis, x-axis. And last time we reflected it and sent it into the second quadrant. This time we're going to send it into the third quadrant. So we're going to reflect it first. So let's reflect it over here. Okay, so if that was the case, we said, well, let's put some dummy numbers in here. Come on. This is, let's say that we're 3, 4, and r equals 5. Remember, it works for anything, but I find it useful just to have some real numbers. Real numbers. Yeah, see what I did there. But they're integers. In fact, anyway. So we've got our real numbers that we can compare. So we can say, well, if that were 3, this one would be negative 3, but this one would still be 4. In other words, the y value is the same, but the x has reflected, so it becomes negative. So in terms of our a's and b's, this was negative a, this was still b, and r stays r. Okay, what we're doing in this one is we're going one step further and saying, well, what happens if we go, let's go blue, shall we, and say, let's reflect it down into this third quadrant. Okay, what are our coordinates going to be? Well, let's do it with our a's, with our real numbers. So if this were negative 3, this would still be negative 3, right? Still the same distance left from the x-axis, it's still negative 3. So in other words, it's still negative a. It's the same, it's the same. Okay, then into, sorry, can I just fix that to go, this was negative a. Okay, now this part here, if this part up here, this number were 4, well, it's been reflected, so this one would be negative 4. So in other words, instead of it being b, it's now negative b. And r has stayed r. R is always positive. If r started out as 5, r would still be 5, r would be 5. We're only going to deal with the a's and b's, but as I said, I think the real numbers give it a sense of, oh, that was negative 3, that was negative 3 still. Okay, you get what I'm saying. Let's have our original trig functions ready. Sine theta, so there's theta. Sine of theta was just y over r, so b over r, because b is our y value. Okay, sine, cos, tan. Cos doesn't exist by itself, it's cos of theta. Cos is adjacent over hypotenuse, or x over r. So our x value is a over r, and tan of theta, must be tan of an angle, is opposite over adjacent, b over a, or y over x. So b over a. Okay, so we're going to see how these compare. Now, I'm going to start with the kind of, not the cheat, but very solidly founded CAST, which trig ratio is positive in the third quadrant. Tan it is, right? So I want to say, based on what we said last time, sine theta, and now we're going to look at theta, sorry, let's get this the right way around. Sine of 180 plus theta, I'm going to posit is just negative sine theta, because sine is negative over here and it was positive over here. Let's check out what I'm on about here. So this angle all the way around here, this is a straight line, so this would be 180. So if we went round to 180, that's how far we'd get, but we're going another theta around. So this full angle is 180 plus theta. Why? Let's just run through that again. If that's theta, this is also theta. So the angle all the way around, well, the angle up to the straight line is 180. And how much further are we going? Another theta. So this whole angle is 180 plus theta. Let's run through our trig ratios. Sine of 180 plus theta. Sine, we said, was y over r. right? It's getting there. Y over R. I say that because it's interesting how different people remember it or get there. Not sure where you are in your journey of just going, oh, it's Y over R. Why does he keep saying that? Or others going, well, sine is opposite of our hypotenuse, so it's Y because it's this vertical one over R. Okay, I'm getting into it. I'm not sure. Whatever. So 180 plus theta, so it's Y of R. Y value is negative B. And R value is still R because it doesn't change. So in other words, this here looks the same as sine theta. Only difference, negative, positive. So in other words, sine of 180 plus an angle is the same as negative sine of that angle. Let's check it out. I've stuck with 20 each time. So I'm suggesting that sine of 180 plus 20 negative 0.34, I'm suggesting that that should be the same as just negative sine of 20. Because it was minus b over r is 180 plus, and this is b over r. So, let's check it out. Sine of 20 should be negative that same value. Well, it's the negative of it. The previous one was negative. So let's just make sure we've got that. Sine of 180 plus 20 times 20 is going to get us in trouble. Plus 20, negative 0.34. So sine of theta, I'm going to have to make it negative to get the same thing. So negative sine of 20 should give us the same answer. And there it is, negative 0.34. Cast diagram to remember these, I think, is useful. CAST, tan is positive, so that's that. So let's just see what we think the others are. Cos 180 plus theta. By this way of remembering it, well, tan's positive, so this must be the same as negative cos theta. And tan of 180 plus theta, well, it's positive in the first quadrant, positive here. So these two, I reckon, are just going to be the same. Let's check it out. Cos 180 plus theta. So cos of this big angle going round. Cos adjacent of our hypotenuse, or x over r. The x value is negative a now. So it's negative a. R is still r. Hey, look at that. This one here, I'm going to put a little star 2. It's almost the same as this one, except it's just negative. So in other words, cos of 180 plus theta is just negative cos of theta. So same kind of idea. Cos of 180 plus 20 is going to be, should be a negative value because we're in this quadrant. So negative 0.939. Let's go negative 0.939. Don't worry about rounding off. I'm going to say that should be the same as negative cos of 20. There it is. Same answer. So just a nice way, as I said, just recheck yourself. Yes, now I've got the confidence to go forward and just say, well, what about tan of 180 plus theta? Tan y over x opposite over adjacent. So the y value is negative b. The x value is negative a. Oh, negative divided by negative, positive, b over a. So in our third star, aren't these just the same? So isn't tan of 180 plus an angle just the same as tan of that angle? They're our next set of reduction formulae. So again, if I asked you what tan of 224 is, not 224, sorry, 225 degrees, and I ask you, do it without a calculator, but reduce it first is what we're asking. Okay, well, I know this is the same as tan of 180 plus 45, right? 225 is just 180 plus 45. Okay, but tan of 180 plus an angle from our reduction formula is just the same as tan of that angle there. And this is, as I said, something we're just remembering as we use more. And tan of 45, I know it should be 1, but of course, who's going to know that I didn't just quickly go tan of 45, oh, that I can't use a calculator, tan of 45, 1. cool. I mean, I'm not going to say, I see you using your calculator there, but this is the work that we want to see. This to this, tan 45. Of course, we can just say is 1 and check it on our calculator. So there's our second set of reduction formulae, 180 plus, and here they are over here.